Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aiman Farhan bin Nosham. My matric number is 14DTP21F1036.
My name is Muhammad Afiq bin Halim. My matric number is 14DTK21F2002. Now I want to.
My name is Muhammad Fikirullah bin Rosli. Matric number is 40 DTP 21F1049.
Assalamualaikum, my name is Muhammad Nur Haikal bin Azmi. My matrix number is 14DTP21F1900.
Next, I will present about the topic is area under a curve. For introduction, area under curve in stadium, integration plays a significant part in human daily life, and it is critical that we have thorough understanding of it. Integration has been widely applied in various of sectors around the world, including education, engineering, physics, architecture, electric charge, every value, and many more. Integrally divide the maximum area and volume required to fill a given space. In stadium design, for example, the notion of integration is used to estimate the area and volume of the domes, but turn to equation has a seat has possibly. The area under a curve is divided, multiply little portion and add or integrate until the solution is found. Next, area under a curve x equal axis. For example, area between a curve and the axis from x equal a to x equal b. The area of region bounded by the curve y equal f in bracket s x in bracket the x axis and the straight lines x equal a and x equal b as shown the figure 1 is a equal upper limit lower limit if f in bracket dx.
Now I want to explain about region bounded by a curve and the x-axis. The value of A and C are positive when the area is above the x-axis. The value of B is negative when the area is below the x-axis. In this case, to calculate area, we must add modulus symbol to get positive value. Okay, for the question 1, the diagram shows part of the curve y equal x power of 2 and then find the area of the shaded region. Okay, for the solution, the maximum is 3 and the minimum is 1. Y dx. We must search the y and the maximum is 3 and the minimum is 1. X power of 2, and we integrate the x and get x power of 3 per 3, and then 3 power of 3 per 3 minus 1 power of 3 per 3 and get 2 per 3 unit power of 2. Next, area under a curve, y-axis. Area between a curve and the y-axis from y equal a to y equal b. The area of a region bounded by the curve x equal f bracket y. The y-axis and the straight lines y equal a and y equal b as shown in figure 2. There are three scenarios to consider when finding the rounded.
The value of A and C are positive when the area is right the y-axis. The value of b is negative when the area is left the y-axis. In this case, to calculate area, we must add modulus symbol to get a positive value. Question 2. The diagram shows part of the curve y square equal to x minus 2. Find the area of the shaded region. The solution of this graph is integrate upper limit 3 and lower limit 0 into x dy equal to integrate upper limit 3 lower limit 0 y square plus 2 dy y cube over 3 plus 2y upper limit 3 and lower limit 0 3 cube over 3 plus 2 3 minus 0 and the answer is 50 unit square.
Region bounded between the two curves or lines. The method for determining the area between two or more curves is an important application of integral calculus. It lets us determine the area of non-standard shapes by evaluating the definite integral. There are three main steps to this process. They are: first, graph the two or more equations. Second, determine the points of intersection. And the last one is set up and evaluate the definite integral. Question 3. The diagram shows part of the straight line y equal x per 2 and curve y equal x2 minus x. The intersect given are 0, 0 and 3 per 2, 3 per 4. Find the area of the shaded region. This is the solution of the question 3. Conclusion. From this presentation, we have learned to solve problems using integration. As stated in the question, we are required to find the area of the shaded region using integration method. To find the answer, we have to apply integration method. Moreover, we also enhance our skill on sketching graph and finding the limits of the shaded region. With integration as mathematical techniques, we have been able to reach the solution of the different methods used. The method brings a simple and clear way tasks can be used for practical data. In summary, we can say that mathematics are very important in our daily life. So we have to learn them as much as possible to understand the world where we live. Mathematics may not teach us how to add love or minus here, but to hope that every problem have a solution.